Thank you. Are you able to hear me? Great. So it was a great session by Alok and Suresh. Definitely insightful, and that's what I have been doing in my organization as well. Right. So when you need to build something for the enterprises, you need to definitely have guardrails. But the other topic related to that is contest engineering that I'm going to talk today. So this is today's topic. So I am Suresh Reddy, a distinguished engineer working for Wells Fargo, and I am based out of Hyderabad. So in my role for the last 1.5 years, I have been building generative AI platform and various applications ranging from building the code generators, code migration tools, right, automating the business processes, chatbots and whatnot, right? So in this entire journey, what we have been doing is talking English. What it means is the prompt engineering, right? So that's the only way you can talk to the models. While we have been doing this, sometimes the model may not really give you what you want or what you ask directly. So that's where you need to use prompt engineering techniques like few shot, zero shot, and so many other techniques. And when they don't work, we had to basically come up with various techniques and use them. And when we used them, we thought probably that is a workaround. But in reality, there is a name for that now. It's basically a science of contest engineering. So let's look at that now, right? What it means and why do we need it or not, right? So with that, so these are the three things that I'm going to cover today, right? So overview of contest engineering. Why do we even need it, right? And then we will talk about what are the challenges and then what are the approaches to overcome those, right? So all of you know, right? So initially, when we started, we used to work with models like OpenAI 3 or GPT-3. It only allows 8,000 tokens as an input contest. Means very small contest. So you have to push whatever you can within that contest limit and make the stuff happen. But now the models are like the recent models can accept input tokens up to 1 million and so on. So can't I just put everything or stuff everything into the contest and let the model decide what to pick, right? So that is the thing that we will look at, whether it really works that way or we need to do something, right? So with that, let me move on. So this is very familiar to all of us. So the good old prompt engineering, where you have a task, you have a contest, you give it to the model, and you get the output. Very simple, right? And we used all of it, right? We all used this. And this particular example was the first one like I built like 1.5 years ago. I was showing this demo to every other person in my bank. And every other business or product owner used to see this and get excited about it and say that, okay, I wanted to use this. Or I wanted to automate my process using this particular thing, right? So and then we were also happy that there is a lot of traction about it. And then when we started building the solutions in that specific contest or business, that's when we understood that the life is not going to be this simple, right? It's not going to work that way. And that's where we had to twist it and tweak the prompts to make it work, right? And let us see. So there are two types of applications typically, right? So we all must have seen direct prompting to the models, but the other variation is the retrieval augmented generation or a RAG set of applications, because the enterprise applications typically don't ask the model for answers because the model may not be aware of the institutional knowledge related to the bank or processes and so on. So that's where we had to feed in some information to it so that it can answer the question based on the context that we provide, right? So in this particular RAG, if you see, so there is a question from the user. We vectorize all the information beforehand in the vector DB. So we try to find the similar chunks. And then we give this question as well as the contest as an input to the model, and then we'll get the output, right? So this, most of you must be already familiar with this pattern, right? So not a big deal, as long as you do a good job of identifying the right chunks, mostly this will work. The second pattern, which is very prevalent nowadays, is the agentic applications, right? So here what happens is, we give a goal to the agent, and the agent will be leveraging the model on one side and a set of tools to interact with the environment, right? Be it your existing APIs or be it your existing data. Somehow you need to marry these two things, the LLM on one side, the tools on the other side, and then agent has to reach that particular goal by leveraging these two things one by one, right? So the challenge here is the agent has to do a lot of work. It has to talk to multiple vector databases, various data sources, and bring all the context. That's one. Second thing is it has to identify the tools that are relevant, and it has to execute those tools, come back and give those results back to the LLM. That is the second problem. The third thing is it also has to maintain the history of what has been done so far and what is it that I am going to do now, right? So it has to do a lot more work, unlike the RAG scenario. And all these things you have to do within the constraints of the size of the contest and the cost, right? These two things it has to keep in mind, and it has to orchestrate this entire activity and still achieve the goal. So it's a bigger challenge, right? But is it really a challenge given the current set of models can facilitate bigger contest length? So let us see the reality, right? So the latest models like GPT-4, right? Gemini 2.5 and all that, if you see, at least there is a 100K tokens minimum contest they allow, right? These are the state-of-the-art models. There are smaller models as well, but let's take these models because these are sophisticated and they can reason well as well, right? But one of the research shows the other side of it. If you see the contest window and the number of tools in the agentic application, most of them are not successful if you have a lot of tools or if your contest size is too big, right? What worked very well is the last row, where my contest window is limited, my number of tools is limited. I can still make the stuff happen with faster execution time and less power consumption, and that's going to save a lot of money for the organization as well, right? This is the finding, and which is still indeed true even today, right? And this is the research from so-and-so source, you can look at it, right? So what happens if you go beyond 32K tokens or 32,000 tokens is basically the agents are going to drift, right? What was the goal that you initially give, they forget about it. They go in tangent and they'll do something else, right? That's one problem. And then, of course, because the contest length is too big, they keep sending the same set of tokens, and it is going to cost a lot of money for the enterprise at the end of the day, right? And it degrades the overall performance. So these are the challenges that we have today, right? So how do we fix them? So that is the engineering called contest engineering. Let us understand that, right? So contest engineering. So this is the definition coined by a person called Andre Karpathy, who worked in bigger organizations like OpenAI and then Tesla, self-driving car and so on, right? So he's a guru, AI guru I would call it. So he coined this term, and he says, contest engineering is all about an art and science of fitting the contest with the right information dynamically, right? At this step, this is the contest that I need, so plug it in, right? It's not going to be static anymore. Like at the beginning, you decide this is my contest or these are my set of documents. I always feed these documents no matter what you need to do, right? That's not how it works. But given a limited contest size, how can I put the right information so that the model can do a better job, right? So if you look at this particular analogy, I think it will be easy to understand. If you assume LLM as a CPU, and it has a limited contest window called like a RAM, so like a typical computer works, right? It can only load something into the memory and work on it at any time. So similarly here also, as an engineer, your goal or your role is to load whatever is the necessary context for the given task at that moment to the model, so that the model can do the right job, right? And then let's look at the context. What context means in the context of agentic applications is going to be the prompt. So prompt engineering is no different from context engineering. In fact, prompt engineering is a subset of context engineering, because your prompt is also part of the overall context that goes to the model, right? And then any RAG context that you are retrieving from various other sources, the tools that you are giving to the model, and then there is a long-term memory and short-term memory. Short-term memory is, let us say you are trying to book a travel plan, which requires you to book a flight, a hotel, and so on, right? So let us say you started booking the flight and then you are at the edge of booking the hotel, then you need to know that you have already booked the flight from so-and-so to so-and-so place, right? So that is the short-term memory. The long-term memory is basically the user preferences. So let us say I stay in Bangalore and I'm a vegetarian and so on, right? So these things, if the model keeps it in long-term memory, so next time when you ask any random question, not even related to the contest, current contest, it should be able to refer those preferences and answer the question accordingly. So on one fine day, you wake up and say, I wanted to have some recipe for some food, then it should automatically figure out that you are a vegetarian, and then it should give you the vegetarian recipe automatically. So that is the long-term memory. So this is all going to be the part of the contest, right? So contest engineering is, again, going back to the definition, art and science. So what does it mean? So the science is basically the set of techniques that will be given to you. Art is when to use which technique, right? You all must have studied design patterns in Java or in other language, right? Learning the design patterns is the science. When to use which pattern is the art. So similarly here also, you will come to know a lot of techniques. We'll see in the upcoming slide. But use the right technique in the right place is the art. Let's look at it. So one problem with any agentic applications or any LLM applications where they fail is if we don't send the right information in the contest. And that's what we call it as a contest rot, right? So when the contest rot happens, it's going to it will have distractions and the quality ultimately will be suffering, right? So there are 4 such problems. Let's go through one of them one by one. So contest poisoning is the first one. So what it means? So let us say I am using some information from internet, right, for my as a contest, right? So let us say someone has basically put some document saying that if there is a keyword like fee refund, this is the way to solve this particular problem, right? Or if someone says reset the password, this is the way you need to solve it. If someone sets it like that, but let us say in my program, without knowing that someone has done like that, we will basically take all that information and feed it to the model. And let us say we created a chatbot out of it. When someone comes and asks this question, I want to reset my password. So that guy will be giving some information which is not related to your institution or organization. Then what happens? Everybody follows that, and it's going to be a phishing attack ultimately, right? So that is what is poisoning. So how do you handle that? You need to strictly filter them, right? Whatever the input that's going back to the model, you need to filter them for the right information. And that is where the guardrails that previous speakers have spoken, right? That's important. So the second one is the distraction, right? So let us say I am solving a code-related bug fix, right? I want the model to help me to fix a particular bug. What I can do is I can dump the entire log from my Splunk or wherever it is, right? And I can also put all my entire code base to the model and say, okay, this issue came, so tell me how to solve it, right? That's a naive way of doing it. Then the model may be looking at a lot of context, which it may not even need to solve that particular problem. But if you can filter out the relevant parts of the code, and if you can give the relevant parts of the log, there is every chance that the model can do a better job, right? That is what is distraction, right? If you give so much of information, the model gets, again, distracted. And that's where you need to use techniques like RAG, which we have seen in the earlier slide. And the third problem is the confusion. So if you give so many tools to the model, right? So in our previous slide, we have seen, right? One research shows that you give more tools, the model gets confused, right? But if you can basically limit the number of tools that you are giving to the model based on the context or based on the problem at hand, there is every chance that the model can do a better job. So one example could be, let us say, I am dealing with GitHub and I am dealing with Jira, right? Both of them have issues, right? It is called issue at the end of the day, right? If I just say create issue as one of my tools, if I give create issue with respect to Jira as well as GitHub, there is every chance that the model gets confused. So you need to be very specific. If the model is, if the problem that we are trying to solve is related to Jira, use this particular tool, otherwise use this tool and all that. So you need to be very explicit and clear when you are giving the instructions in the context for the confusion part. And the last one is the clash. If you give any contradictory statements, let us say one of my, let us say there is a policies related stuff or chatbot that I created in my organization. And one of the PDF says the PTO eligibility for any person is like 30 days. And the other PDF says it is 40 days, right? Because the previous document is related to 2024, the latest document is 2025. And if I feed both of them into context, then what happens? The model gets confused. And these are contradictory things. It doesn't know when you ask a question, what is it that I have to do? So that's where we need to be prioritizing which one should be considered if we have a conflicting situation and all that. So this is one of the other techniques. Right? Using those techniques in the right places, you will be able to handle that. And few other techniques. The RAG is one technique that I already explained anyway. Right? And then tool loadout is the another thing. Right? So this is also a very useful technique. So let us say if I have access to 20 tools, I don't want to plug in all the 20 tools into the model. Rather, based on the question or the task at hand, I'll do a RAG on the top of the tool definitions. Even if I have 20 tools, I'll only select 5 tools that may be relevant at this juncture and only send these 5 tools to the model. So that way it can do a better job. Right? So context pruning, summarization, and context pruning is all about you look at the existing context so far. Right? Let us say we are running a multi-turn chatbot, wherein you ask a question, I'll give the answer and so on. But at some point, I can basically summarize what happened so far and keep that as a simple context. So far, the user has tried to book the flight. Now let's try to book the hotel. Right? So that way, the model doesn't need to consume unnecessary tokens because that information is not going to be useful anyway for booking the hotel. Maybe whatever is really relevant is the location, from where to where this guy is traveling and what dates they are traveling. That is the only relevant information to book the hotel. So let us summarize, prune the existing context and put only whatever is relevant in the this one. Context summarization is similar. So if you have a whole lot of information, summarize everything and say that so far we have booked the flight and now we are going to book the hotel, right? So context quarantine is basically isolating. Like if you have multiple tasks, like booking this hotel, again, I'm going back to the same example, but booking the hotel, you give it to a different agent, and booking the flight to a different agent, and booking something else to a different agent, so that each of them maintain their own context, so that the likelihood of model getting confused is going to be minimal. So the first task is, or first step is context offloading, wherein we basically offload the unnecessary context to the secondary storage. Like we all do it, right? Whatever is relevant, we will put it in the cache. Whatever is not relevant, put it in the disk or database. If you need it, you load it, use it, and then throw it back. So that way, the amount of context that you are sending across is going to be minimal, and the likelihood of LLM making errors is going to be minimal. Right. So this is not the slide that I want to show. I think something, this is a previous version, but anyway, let me still cover this. I mean, the question itself is wrong. Anyway, so what I wanted to say in this thing is, so can we switch to the other PPT because the latest version doesn't have this example. So the example that I was trying to show is basically so let us say I have a bug in my code, I wanted to fix it, right? So the way you need to typically do that is, instead of throwing the entire code to the model, you just say, I have this so-and-so bug, give the stack trace, and then show the code snippets related to that particular set of files or the method names that you find in the log, right? And then you can also say, these are the tools that are available at your disposal, so that you can look at the previous or related bugs using these tools. And then you can also show, this is the previous solution that you gave, I tried, but my test cases have failed, right? So like that, you can go step by step and give that context. Sorry. No. Okay, fine. So like that, we need to fire that prompt anyway. I don't have the latest slide somehow, but that's okay. So the key takeaway is basically, in spite of following all these contest engineering philosophies, right, there is still chance that the model can do a bad job. So within the current constraints, these are the techniques that are found in the industry. So use them. It is more of a damage control than final fix. So, but these 3 points are important. Always retrieve and provide only relevant info like RAG and so on, right? And summarize the previous context so that you can give a smaller context to the model or only relevant context to the model. And use system prompts and tool prompts in the appropriate sections, right? That was my example in the previous slide, but somehow we could not see that latest slide. But these are the 3 things. You can refer to internet anyway to understand this. So ultimately, so prompt engineering starts your journey, but contest engineering is what that takes you to the target. Yeah. With that, thank you very much. And if there are any questions, I am happy to answer.